For centuries, humanity has lived alongside what you could call a profound philosophical silence. We share our homes, our lives, our whole planet with billions of non-human companions.
From the dogs at our feet to whales in the deep ocean.
Right, but their actual internal state, their language, has always been locked away behind what we call the language barrier.
Hmm.
And if we're being honest, our own interpretation skills are, well, they're embarrassingly flawed. I mean, I remember thinking my own dog was just being stubborn.
Oh, of course.
Turns out he was showing these subtle signs of joint pain. And we've learned that humans are actually quite poor at reading even basic canine signals.
Mm.
We mistake playfulness for aggression all the time.
Or anxiety for simple disobedience. It's a
Yeah.
classic case of projection.
Exactly. We think we're communicating, but mostly we're just guessing.
Well, that historical gap, that fundamental misunderstanding, is now dissolving. And it's not because humans suddenly grew more sensitive. It's because AI has become this unprecedented objective listener. So our mission in this deep dive is to analyze exactly how artificial intelligence is moving beyond just simple audio translation
Okay.
to actually decode the inherent intent of non-human species. We're pulling together some cutting-edge academic research with some really surprising consumer tech breakthroughs, especially from CES 2026.
So we're looking at the research and the real-world application.
Yes, and they signal a huge immediate shift.
And we are specifically diving deep into the technical scaffolding here, the thing that lets AI quantify an animal's mood and needs. It's a concept researchers are calling bioacoustic intent.
Hmm.
And from there, we have to confront the ethical frameworks. Because once you understand language, you have to confront the question of rights.
To really appreciate the scale of this breakthrough, you have to look at the technological foundation. For years, the main hurdle in this kind of research was just a scarcity of data.
Right. There's not a library of books you can just check out.
Exactly. Unlike human speech, which is digitized everywhere, collecting a huge contextual library of dog barks or whale songs, and then accurately tagging them with the right behavior. It's a massive logistical challenge.
So researchers got creative, and that leads to this fascinating piece of technological repurposing. Instead of building new models from scratch, they looked at our existing linguistic AI. The University of Michigan research, which is a core source for our deep dive, used the Wav2Vec2 model.
And this is where it gets really interesting. Wav2Vec2 was a deep learning model designed specifically for human speech analysis.
For us.
For us. It's excellent at listening to a person and distinguishing all those tiny acoustic nuances, tone, pitch, accent, emotional inflection, even if it doesn't know the actual language being spoken.
So they took this sophisticated human language framework and what? They just plugged in dog data.
Essentially, yes. They trained the Wav2Vec2 model using vocalizations from 74 dogs in very specific controlled contexts.
Like what kind of contexts?
Well, you had playful barking, anxious whines, aggressive barks at a stranger, positive squeals during feeding, and even negative squeals during, say, frustration.
And the results.
They were immediate and profound. The AI wasn't just classifying sounds, it was listening to the very structure of the communication. It could accurately determine the dog's breed, sex, and age just from the sound.
Wow.
But the real breakthrough was its 90% accuracy in determining the true context, the emotional intent behind the sound. It could tell you definitively if a sound was playful or if it posed a threat.
Okay, this success hinges on a technical concept we really need to grasp. Embeddings. We talk about this a lot with human language models, but applying it here seems to change the game.
It fundamentally changes the game. Think of it visually.
Yeah.
When an AI processes human language, it doesn't just treat words like dictionary entries. It translates every single word into a complex geometric data point. So if you plot the word dog, it exists in this quantifiable space. It's close to friend and leash, but it's very far from catastrophe or calculus.
Yeah.
That geometry is the word's meaning and context.
So let's unpack this for the non-human world. If a dog barks excitedly when a toy appears and then barks in a similar but slightly different way when its owner comes home, is the AI creating a geometric plot of that bark? And are those two barks lying close together in that space because the intent is similar?
Precisely. That is the core insight. The proximity of those acoustic events in that geometric space quantifies the relationship between the sound and the behavior. It's creating, in effect, a 3D mood map.
A mood map.
It transforms acoustic noise into quantifiable semantic meaning. This is the very definition of bioacoustic mapping. The AI doesn't need a Rosetta Stone for every dog. It identifies the inherent structure of the communication itself.
which forces us to confront the fact that animals actually possess a systematic language. That structural breakthrough takes us from pure research directly into these high-stakes applications in, real-world behavior and wellness. If we can map the intent, we can predict.
Yes. We see this scaling globally with organizations like the Earth Species Project. They're pioneering what's called multimodal data analysis.
Meaning multiple types of data at once.
Right. They'll use advanced tags on animals, say a sperm whale, that simultaneously record audio, visual, and motion data. By correlating the whale's song with its physical actions, they build these complex models that allow them to predict behavior from sound and vice versa.
And that is the practical realization of decoding bioacoustic intent.
That's it.
And this capability has immediate, profound relevance right in our homes. The pet tech industry is pivoting. It's moving from simple monitoring, what happened 3 hours ago, to what they're calling predictive wellness.
Which is really about what might happen over the next 3 days.
So it's about catching those subtle shifts that happen before a crisis. Pet owners, we frequently miss what are called micro shifts in behavior.
Especially in animals like cats or certain dog breeds that instinctively hide their pain or illness.
Right. So this new generation of AI can detect these tiny anomalies, like a sustained 20% drop in food intake or a sudden spike in water consumption over a couple of days.
And it detects them days before any clinical visible symptoms like limping or vomiting even appear. This allows owners and vets to act proactively, potentially saving the animal from a much worse outcome.
And to get that level of precision, that continuous background monitoring the hardware had to evolve, we're moving beyond awkward wearables and collars.
Oh, yeah. The trend is definitely toward contactless, unplugged pet recognition.
So this is basically the end of the clunky RFID tag.
It is. High-precision visual sensors now deploy something a lot like Face ID for animals. They identify pets based on unique facial contours, coat patterns, or even micro-patterns in how they walk.
Which is absolutely vital for accuracy in multi-pet households. So the system can tell the difference between two identical tabby cats, for instance.
In milliseconds. To ensure the health tracking and nutrition is assigned to the right animal.
And that sophisticated vision AI works alongside crucial contextual awareness. So with new standardized integrations, a camera can recognize a pet at a feeding station and then automatically tag that event as a feeding event.
Right, into a central wellness timeline, which solves the whole app fatigue problem where you're trying to connect all these different data points yourself. Now, the context is just baked in.
So that level of instant contextual intelligence, that requires a fundamental change in where the computing actually happens. The industry is making a firm shift from cloud-first processing to edge AI.
And a privacy-first design is a huge deal.
The benefits of local on-device processing are massive. First, there's privacy. Devices processing video of your living room now handle that data entirely locally. The footage never reaches a distant corporate server.
Right, and for systems tracking these acoustic mood maps, the resulting embeddings, that geometric data are stored locally using integrations with specialized databases like ChromaDB.
What does that do?
Well, it's essentially a local library optimized for this kind of vector data. It stores and quickly searches those geometric representations of your pet's intent, so the AI can pull up historical context instantly, without the bandwidth or security risk of a remote server.
And second, it just improves resilience. I mean, on-device processing means that if your home Wi-Fi fails, the device can still recognize your pet, process its schedule, and dispense food or medication.
That kind of reliability is critical when the tech is managing potentially life-saving health variables.
And this whole shift toward local intelligence, it's finally being ratified by broader standards. Matter 1.5 integration is the key here.
Absolutely. This recent release officially supports standardized AI camera streaming.
Which means pet health alerts are no longer trapped in some proprietary app. They can be integrated seamlessly into your existing smart home dashboard right alongside security and climate notifications.
Pet care is now officially just a part of the daily digital routine.
And we're seeing this applied immediately in the robot companion space. Look at the FrontierX robots. You have Vex, the AI-powered pet camera sidekick. It uses on-device large language models to analyze footage, find key moments, and create these moving narratives or highlight reels from a low-angle perspective that mimics the pet's view of the world.
It literally tells the story of the pet's day to the owner. And its counterpart, Aura, is the human-facing companion. Aura uses built-in edge AI for direct emotion detection on the owner.
On the human.
On the human. It analyzes facial expressions, tone of voice, to infer your mood if you're stressed, tired, or excited. And then it can suggest activities or play a calming playlist. It's a truly responsive system.
So as this technology gets so deeply embedded in our homes, we have to turn to the profound dilemma that comes with decoding non-human communication. This isn't just about optimizing feeding times anymore.
No, this is about potential dialogue and therefore responsibility.
The philosopher Asa Raskin, he captured the inherent risk of this leap perfectly. He said, "Because of the nature of large language models and AI, we will be able to communicate fluently before we fully understand what we're saying."
And that is the high-stakes issue right there. If we can not only decode the intent of a whale's song, but potentially manipulate or synthesize that communication.
To, say, use generated sounds to influence their migration patterns.
Precisely. Then we need immediate and critical safeguards. This means we need guidelines akin to a prime directive or a Geneva Convention for cross-species communication.
An ethical firewall.
Yes, to address public concern about misuse before it happens. If we open the door to conversation, we have to establish the rules of engagement first.
And public sentiment is already grappling with this. A recent global survey reveals a remarkable level of acknowledgement. 94% of people believe animals have emotions, and 91% believe they have language.
But the really interesting one is that 63% believe animals possess culture, which moves the conversation beyond mere biology and into complex social structures.
But that acknowledgement is, it's tempered by a deep caution toward the technology. A staggering 85% of respondents want strict, enforceable rules for companies profiting from this decoding tech.
The primary global concern is clear: preventing the exploitation, manipulation, or harm of animals for commercial gain, especially if the communication becomes two-way.
And that leads to this deeply provocative question about power and governance. If they have language and culture, well, shouldn't they have a voice? The survey showed significant openness to the idea of multi-species democracy. 60% of people believe animals should participate in human democracy in some capacity.
Whether through advisory roles or maybe representation through human proxies, that number 60% signals a real readiness for radical policy changes.
And when they were asked which policy areas should prioritize animal input, environmental laws were number one at 77%, followed closely by food systems and agriculture.
It's a strong public mandate for governance that incorporates non-human perspectives into decisions that directly affect their lives.
Finally, we hit the issue of data ownership. If a recording of a dog's anxiety bark is the key to a $1,000 piece of vet data, who owns that bark?
A very complex question.
And public opinion is highly divided. 40% favored ownership by the community protecting the animals. 33% thought the human recorder should own it. But a remarkable 17% believed the animal itself should own its song.
That lack of consensus just highlights the urgent need for new data rights frameworks for non-human species. The fact that 1 in 6 people already believe an animal should own his own data means this isn't a theoretical debate anymore.
It's an immediate legislative challenge, and it's being driven entirely by this new technological capability.
Yeah.
So what does all this mean for us? For you listening? We are clearly at an inflection point where AI is dissolving the language barrier. It's transforming our relationship with animals from one of dominance and guesswork
To one of potential dialogue and, more importantly, legally required stewardship.
And this shift is not theoretical. The rapid practical integration of these advanced AI concepts, from embeddings and Wav2Vec2 to Edge AI and Matter 1.5, it's already reshaping our homes.
This collective breakthrough, it really represents the fulfillment of the 20-year promise, that long-sought ability to understand non-human consciousness.
And by the end of 2026, these technological advancements will have permanently changed the human-canine bond. We'll be moving beyond guesswork toward truly responsive care based on quantified bioacoustic intent.
So if we can read the mood and intent of our companion animals with quantifiable, high-confidence certainty, how radically will our definition of responsibility change? What is the first thing you would ask, or maybe more importantly, listen for, if you knew your pet could communicate its needs perfectly?